Section 2-1 is on inductive reasoning and conjecture. Inductive reasoning is a type of reasoning that uses specific examples to arrive at a conclusion. An example is when you assume an observed pattern will continue. You look around you and you observe what's going on and assume that that pattern will continue. A conjecture is the conclusion that you reach using inductive reasoning. So here are some examples. Write a conjecture that describes the pattern in each sequence. Then use your conjecture to find the next item. So in example number 1, I have 2, 4, 12, 48, 240. Well, I know that when I go from 2 to 4, I'm multiplying by 2. When I go from 4 to 12, I'm multiplying by 3. 12 to 48, I'm multiplying by 4. And 48 to 240, I'm multiplying by 5. So my conjecture is that I multiply by n plus 1. By n plus 1. In other words, 1 more than the previous time. So according to my conjecture, to get the next number, I should multiply by 6, and that would give me 1,440. Example number 2, 1, 4, 9, 16. Well, it looks to me like all of those are perfect squares, so my conjecture is that this is the squares, the sequence is the squares of counting numbers. Because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So by that, my next number should be 5 squared, or 25. Next set of examples, make a conjecture about each value or geometric relationship. Provide an example to support your conjecture. So the sum of an odd number and an even number. So the best way to do this is to just try a couple examples. So 3 is odd, 2 is even, I add them and I get 5. Another odd number would be 7, and an even number would be 4, and I get 11. If I do 5, which is an odd number, plus 8, which is an even number, I get 13. So I think my conjecture is going to be that when you add an odd number, that an odd number plus an even number gives me another odd number. Example 2, for points L, M, and N, LM is 20, MN is 6, and LN is 14. So I have points L, M, and N, and the total distance from L to M is 20. Okay, but it says from M to N is 6, and from L to N is 14. So a conjecture that I could make is that L, M, and N are collinear. The only way for their lengths to add up would be for them to be in the same line, and that N is between L and M. To show that a conjecture is true for all cases, it actually must be proven, and we'll be doing that later on in this chapter. But it only takes one false example to disprove a conjecture. This false example is called a counter example. Let's take a look at a couple examples here. Determine whether each conjecture is true or false, and if it is false, provide a counter example. Number 1, if two angles are vertical angles, then they are congruent. Well, what we know about vertical angles is that those are the angles that are formed when lines intersect, And angles 1 and 2 would be vertical angles, and they are indeed congruent. We learned that in the last chapter. So that's actually a true conjecture. So no need to provide a counterexample. Example number 2, if two angles are supplementary, then they form a linear pair. Well, let's see, are all pairs of supplementary angles, do they all form a linear pair? Well, I'm thinking if this angle here is 150 degrees, and this angle here is 30 degrees, they are indeed supplementary, okay, but they do not form a linear pair. Let's go ahead and name these so that I can write something here. So angle A and angle B are supplementary, because 150 plus 30 equals 180, but they do not share a common side, so they're not a linear pair. That's sloppy. Not share a common side, so not a linear pair. Okay, this is a good example of doing a counterexample. I've shown a picture here of two angles that are indeed supplementary, but they don't form a linear pair. Remember, a linear pair has to look something like this, where the two lines are the two angles are supplementary, but they form a straight line. Oh, I forgot to say false. That's actually false. Okay. In our last example here, if you wear a plaid skirt, then you go to Carondelet. Well, do all people that wear plaid skirts go to Carondelet? No, they don't. That's false. And a counterexample would be Susie wears a plaid skirt, but she goes to St. Francis. So that's a counterexample, because not everyone that wears a plaid skirt goes to Carondelet. My counterexample is Susie, who wears a plaid skirt, but she goes to St. Francis.